We are about to embark on a cosmic journey that will take us to the edge of the visible universe and back to the beginning of time. Traveling in an extraordinarily fast spaceship, we leave the Earth behind and travel through the solar system, pausing first to marvel at Jupiter with its great red spot. Next, we speed still further out, passing Saturn with its spectacular rings and many moons. The Sun is just one of the 100,000 million stars that make up the Milky Way. The Milky Way is a spiral galaxy with a rotating disk of stars and gas clouds. New stars are born in these clouds at a rate of about one new sun every year. Andromeda, our nearest large neighbor, is a spiral galaxy a mere 2 million light-years away. We now travel in the direction of the Virgo cluster, a teeming metropolis of galaxies in our cosmic backyard, around 50 million light-years away. The cluster mostly contains elliptical galaxies, roundish objects that stopped making stars billions of years ago, having run out of gas. At the center of Virgo lies a large galaxy called M87, home to a monster black hole that weighs more than 3,000 million times the weight of the Sun. Stars that venture close to the black hole are swallowed up by this cosmic cannibal. Astronomers from the UK and Australia have mapped our cosmic neighborhood far beyond the Virgo cluster. This map of 250,000 galaxies is so big that light takes 3 billion years to cross from one side to the other. As we pull away, the cosmic chart shows how galaxies clump together in a rich variety of structures, revealing an intricate cosmic web of filaments and clusters. This is a supercomputer simulation of the universe that looks just like the cosmic web. Astronomers believe that galaxies are merely the icing on the cosmic cake, lying at the center of vast concentrations of invisible, cold, dark matter. The gravity of the dark matter provides the glue that holds the galaxies together. This dark matter is thought to consist of tiny particles which are very different from those that make up the atoms of stars, planets, and people. Clumps of dark matter adorn the filaments of the cosmic web like beads on a necklace. Where does the cosmic structure come from? The visible universe was once the size of a pinpoint. In a period of extremely rapid expansion called inflation, it swelled to the size of an orange. This generated tiny ripples in the density of the primordial universe, which left an imprint on the heat left over from the Big Bang. This fossil record, seen today as microwaves, is mottled with hot and cold spots. These are the seeds from which galaxies grow. Dark matter clumps, or halos, are assembled from small fragments that form early on. The gravity of the dark matter sucks material in, with matter flowing along filaments, colliding and coalescing to build ever larger clumps. What began as a tiny ripple grows several billion years later into a halo just like that of the Milky Way. As the dark matter fragments build up, gas collects within them, cools down, and eventually turns into stars. Many galaxies are tossed around as gravity pulls their dark matter together. When the fragments collide, their gassy cores are squashed, triggering the formation of myriads of stars. The early life of a galaxy is full of incident. In middle age, the hustle and bustle subsides, allowing a beautiful spiral disk to grow. The life of a galaxy, from its microscopic beginnings to its present-day splendor, can be recreated in a computer. The computer-grown galaxy is strikingly similar to the real one. It is remarkable and humbling to realize that such cosmic cookery merely requires that the computer be fed a few numbers that describe the Big Bang and the very same laws of physics that govern everyday natural phenomena here on our own small planet, the Earth.